is, there we go. Today is client-side skimming exposed, exploring digital skimming and third-party tracking technologies. Today, we're going to go through a couple different examples of some attacks that occurred in some in, I guess, in internet terms, pretty far back history, but then some more recent ones as well, and how those affect different sites, how they affect payment data specifically today, and then we'll talk about how that can affect other components as well. Gareth, I'll let you introduce yourself first.
Thanks, Jeffrey. Yeah, hi everyone. My name is Gareth Bowker. I'm a PCI technical advisor at Jscrambler. Been working in the PCI space now for around about 20 years or so. I started as a QSA, so PA QSA, did some stuff with card production all the way. And for about the last 12 and a half years until right about the middle of last year, I was working at the PCI Council. I was a trainer there, director of training, and then towards the end I was responsible on the PCI side for the PCI Council's own PCI DSS compliance, as well as being a member of the technical working group developing PCI DSS. So yeah, now working at Jscrambler and talking all things PCI here. Jeffrey.
I'm afraid I won't be quite as impressive in that regard. But yeah, Jeffrey Cleveland, the director of the pre-sales engineering group here at Jscrambler. Been here for about 3 years. Really handling a lot of stuff on client side, JavaScript protection and otherwise, which is today's topic. So I think we'll have plenty to add. Today, the idea is to keep things a little bit more conversational. Don't want to just send a ton of information at you, just kind of as a stream. So while we're going to take about an hour, and we will take all the questions at the end. Certainly, if you have questions that are relevant along the way, we'll try to keep an eye on those as we're progressing through. If they're relevant to what we're discussing at that time, we'll try and take them right away. So certainly post those. You can either put them in the chat, or there is a Q&A tool down at the bottom. We'll keep an eye on both of those. Feel free to use either one, and we'll respond there. We'll have a short little demo as well, where we'll show you how some of these attacks work, and then we'll move through to some other topics right at the end. Last little piece, you will get an email with a recording of this webinar, so if you want to share it around or refer back to anything, that will be there for you. And that'll, of course, include all the slides that we go through and all the commentary along the way. But keeping with that agenda, first thing we're going to talk about a little bit of a history around digital skimming. We'll talk about a couple different attacks that come through, either third party or some first party. And then we'll talk about some defenses or ways that you can mitigate or at least detect these types of attacks, a bunch of different approaches, and then make sure that we finish up all the questions at the end. But I believe, Gareth, you're up first with a little bit of background on the digital skimming side.
Yeah, so I thought we could just get started talking about, well, what it is really. So I thought we'd start off by just talking about some of the different terms that we hear, what they mean. You often hear the term digital skimming. You often hear the term Magecart. So I thought I'd talk a little bit to begin with about kind of the history and where these terms come from, and so on. So starting off, is there a difference? The short answer is no. The slightly longer answer is kind of. So the terms have come about differently. Magecart actually started off meaning something slightly different, and it's kind of morphed. So today, when we're using these terms, they really are interchangeable. And I'll talk a bit more about that as we go through the history of this in just a second. And then I thought we could talk maybe a little bit about the types of attack that we hear about. So again, you might hear terms like silent skimming attacks, double entry attacks, and I thought we'd talk a little bit about the difference between these. So silent skimming attacks, these are attacks that are basically invisible to the user. So if you're going to a website and you're making a purchase for something, you're putting in your card details, and you go through the process as normal, and your cardholder data gets lifted, that would be an example of a silent skimming attack. So the process has been completely invisible to you. Cardholder data has been captured by an attacker somehow and taken out, but the process itself has gone through as you would expect it to do. Double entry is slightly different. What this means is that the attacker has got into the payment flow somehow, but rather than the flow going through normally, what happens is the first time through, the attacker is fully in control of the payment flow. They'll lead you through, you'll enter your card details, and then they'll do something like throwing up an error to say, you know, there was a problem with your details, please double check them. And you close that down, it goes back to the payment, but now it's actually the original payment form. So the first time through, the attacker captures those details. The second time through, the transaction goes through as it normally would. These ones are a little bit more obvious because, you know, if you're going in and making a purchase and every single time something goes wrong, you're likely to notice that fairly quickly. So those are kind of probably the most frequent types of skimming attacks that we hear about. And then the ways that these happen, there are lots of different ways, but some of the most common ones that we hear about are things like iframe overlays. So this is where an attacker can overlay an iframe on top of the original iframe and capture details that way. A fake iframe is kind of the same, but different in that what they're doing is they're just replacing the original iframe. So often an overlay attack will work alongside a silent skimming attack. A fake iframe is more of a double entry type of attack because you're putting the details purely into the attacker's iframe in the fake iframe type of example. There's another type of attack as well, which is kind of a fun one. It's called monkey patching. If you've done much programming, this is maybe a term that you're very familiar with. This is where attackers will modify the way that JavaScript is running within the web browser. And so, for example, when the web browser is making a network call to send some data to the server, the attacker will change that function and they'll send the data to their own server as well as to the original server. There are lots of different things that you can do with monkey patching. JavaScript as a language is really, really flexible. It's a really useful feature of JavaScript, but it also is a feature that attackers can use too. Okay, so just as a quick timeline then, in terms of web skimming, the first attacks that I could find mentioned on the web here started sometime around about 2010. I think August 2010 was the earliest example that I could find of this. So this is where an attacker was simply getting into a website. They'd added some JavaScript into the payment page, and they were able to capture data that way using JavaScript and exfiltrating it using JavaScript. Up until that point, there were still, you know, quite a lot of attacks, but generally what attackers were doing then was they were going after the database. A lot of payment websites would store the data themselves. That has changed quite a bit now. People tend to use, you know, service providers with iframes and so on. So attackers back then would often go after the database. And it was around about 2010 where we started to see that shift towards web skimming. 2016 is when things started to really kind of start hitting the headlines. There were some coordinated attacks. There were some loosely affiliated groups that were attacking lots of different websites at the same time. And this is where the term Magecart was first termed. Originally, it was a term to describe those groups. And the reason it was and the types of attacks that they were doing here, and it's called Magecart specifically because it was targeting the Magento open source payment platform. So it's a kind of a shopping cart, open source shopping cart called Magento, and attackers were really going after that to begin with. But as I said a minute ago, that term has kind of changed a little bit, not just talking about the attacks, the specific attacks and the groups. It's now just kind of a general term that means web skimming these days. 2018 is when it really took off. This is when, if you remember, there were attacks like Ticketmaster. That was one of the first really big ones that hit the news. And then not long after that, there was an attack against British Airways as well. And also in this year, there were several attacks against third-party analytics companies here as well. And in 2018, there were attacks against, I think it was Social Plus was one of them, Inventor was another, and they compromised somewhere in the region of 800 e-commerce sites just by targeting those web analytic providers. In 2019, attackers shifted a little bit. They started targeting things like Amazon S3 buckets, particularly ones that were misconfigured. And there were some automated attacks here that compromised somewhere in the region of 17,000 domains. So again, it was quite a big shift and a ramping up. And if we jump forward to today, when I was reading the Verizon 2025 DBIR report, it talked about Magecart in there. It stated that in terms of system intrusion attacks, Magecart attacks only count for around about 1% of all of the system intrusion attacks. But when it comes to payment attacks, that's ones where payment card data is breached. Magecart is around about 80% of those attacks. So it's actually a very large proportion when it comes to payments. And it's worth noting as well that Verizon reported that the threat actors here are largely driven by opportunity rather than by targeting the largest vendors. What that means is that if you're a small merchant and you're thinking, well, why would somebody attack me? Well, that's not really the right way to think about it. The real answer is, why wouldn't they attack you? Attackers are scanning the internet. They're trying to find any types of vulnerable sites that they possibly can, and they will attack you if there are vulnerabilities there and there's the opportunity for them to make some money.
Yeah, and I
Okay.
think it works. I was going to say, just interject real quick. I think it works the other
Yeah.
way too, where if you're a large merchant, you say, yeah, we have a very mature security program. Well, do all of your third parties, right? Do they have the same super mature security program, or are they going to represent that smaller, weaker target that they can use to get into either the big guy, the smaller merchant, somewhere in between, or even better, all of them at the same time, right? Once you get into one component, if everyone's using the same component, you're into all those same sites too. So it kind of goes both
Yeah.
ways.
Yeah, that's entirely true. You can be as mature as you like as a company, but if one of your third parties has some issues, or even worse, one of their third parties,
Right.
sometimes these chains can be, not just third, but it can be fourth, fifth, sixth party that somebody manages to compromise. And if you're running that code on your website, that code is running within the context of your website. And so potentially attackers, quite a long way away from your site can still manage
Yeah.
to impact it. Yeah, absolutely.
They may not even know who the final target is, right? They're really just going after a third party that's vulnerable and then just see what they get.
Right, exactly. In fact, the analytics ones that I mentioned there in 2018, that's exactly what they did. They targeted two companies and 800 e-commerce sites were affected by it. It's, huge, sort of multiplier effect, isn't it?
Yeah.
Right. So I thought we should talk a little bit about the British Airways attack first, given it was one of the big ones that I mentioned there. Whilst it was, several years ago at this point, 2018, it's a really good attack to look at because, as I mentioned, it was a really big attack. It's really impactful, and it's actually really simple as well. So hopefully, as I talk through this, it will actually kind of make sense to you as exactly what the attackers did, what they managed to do, how the attack worked, and how they managed to get the data out. So what they did, the attackers managed to find a website. In this case, it was baggageclaim.britishairways.com. It had some vulnerabilities on it. I believe it was unpatched for a couple of years. They managed to exploit these vulnerabilities and they managed to get in. They were then able to modify one of the files on baggageclaim.britishairways.com. It's just a JavaScript file that was being used across lots of different BA websites. And in 15 days, so between the 21st of August 2018 and the 5th of September, 330,000 customers were impacted. So, for 15 days, that is quite the impact that they had. So, excuse the slightly blurry image here, but you can see there in the red box at the bottom here, that is the skimmer that the attackers managed to put in. I've got a slightly better version of this in just a second, but what you can see here is that they actually managed to get into this modernizer JavaScript, and they simply appended this onto the end. So attackers will do this. They'll find an existing file, a file that is needed, and they'll simply append this code onto the end of it. So this is the JavaScript. And as we kind of go through it, essentially what it's doing here is it's saying right at the start of the page, once the page is loaded, then we're going to add a piece of code to the submit button. That code is going to fire anytime that the mouse button is lifted, or if you're on a mobile device, when that touch event has finished. So when that happens, what it's going to do is it's going to go through the payment forms, the payment form section of the website. it's going to go and find everything that's within that, every single form field that's in there, and it's going to put it into a little variable, so n that's up there. It's adding the name of the field, and it's putting the value in there. It's also getting the name, the cardholder name, because that was stored somewhere else in the British Airways site, and it's adding that in there too. It then converts it into a little JSON object, so it's very easy for the attacker then to kind of have a standard format for them to handle that data. And finally, what it does is it sends it out. So it's an AJAX call here. It's posting it to baways.com and then a bit of URL there. So this was again trying to make it look completely legitimate. Any British Airways staff member who might be looking at that will see that and go, oh, it must just be a shortened version of our domain name if they're not thinking too carefully about it. And it simply sends all of that data across. Really simple, really, really simple. You can see that's 22 lines of code. So the attackers there were able to capture 330,000 card numbers just using this piece of code here. What's interesting with this is that the attackers, had a very simple attack here. You can tell exactly what it's doing by looking at the code. Over time, as we'll see in just a second, they've added other things in like obfuscation and other ways to try to get around protections for this. But in this particular case, given it was one of the early, really impactful ones, attackers really didn't need to do very much. So you can see the code here is really nice and clean, really nice and simple. So that is the British Airways attack. And what I thought I would do now is I just want to show kind of what that looks like in reality. So if you just give me 2 seconds just to get my web browser logged in, which I am, and I'll just share my screen very quickly. And it is this one, I hope. Just hope you're sharing the right window on these things.
I've got your payment.
So what I've done here is I've written a simple Tamper Monkey script. Some of you may be familiar with Tamper Monkey. What it is, it's a way for us to inject scripts into any website that we want to. So what we're doing here is simulating what an attacker might do. If an attacker managed to get into a website, they could run this script here. They could add that into one of the existing files, just like the British Airways attackers did. But this means we're not actually having to break into a site. So it makes it nice and simple just to kind of simulate this. So let me just show you first. I'll show you first of all what it does, and then I can just quickly talk through the code here as well. So I've got a payment page here. Just reload it to make sure it's all there. And when we enter in some cardholder details and we click on make a payment, you can see all of the data has just come through here now. It's just going to reload in a second and then I'll go back to that page. There we go. So as we look through here, there's lots of different input values. And around about a third of the way down, if I remember correctly, here we go. It has captured cardholder's name, the card number that we entered, the security code, the expiration, and then it's put all of this into the JavaScript console here. So I put it in the console here as well, just because it's very easy for us to see, but an attacker just as easily could send it off to a drop server.
And
So
I
I'm
think
looking at
something that people, sorry to interject,
go
I
ahead.
think something that's hard for if you're if you're not a JavaScript developer specifically, or just not familiar with the way JavaScript works. I think something that's always interesting, always gets brought up is like, well, what about permissions? What about some kind of privacy or something, which doesn't really exist in JavaScript, right? There's no real way to say, hey, this piece of script is or isn't allowed to access certain form fields, right? Once that script is there, it can do it at once. And so that's the interesting part is once you've got the script in, from there it's anything. You can use any of the network tools. You can do something as simple as hey, just pull it into a variable. But once that has been once you've got the code in, you can do whatever you want from that code's perspective, even tampering with other code, right?
And in fact, that is kind of one of the benefits of JavaScript as well, of course, because you think about when you're pulling in all these different libraries, you might pull in a menu from one place to give a nice, pretty animated menu. You might have something that is providing some pretty buttons, for example. all sorts of different functionality. Some of it might be doing a payment page, actually building the payment page for you from your payment service provider. All of this could be perfectly legitimate, and you want it to be able to modify that page because you want that pretty button. You want that iframe to be loaded. So it's part of the design of the language that it is this open. But yeah, as Jeffrey was just saying, that is also one of the downfalls of it. Any malicious code that gets in there has exactly that same access as the legitimate code. Right, so I just wanted to very quickly just show this code here. It's very similar to what we just saw with the British Airways one. So literally all it's doing is it's saying when there's a mouse down event, when somebody's clicking on that button, then we're going to just check to see exactly what's being clicked on. So in this case, as part of my building this, I actually had to try to figure out why clicking on a button wasn't working. So originally, I had to just put in some debug text here to print out everything that I was clicking on, found out that it's actually a span that is being clicked on, and then I could just attach this method to it. So it took me about 5 minutes to build this, to figure out exactly what I needed to do, and then I could immediately print everything out in the console here. I've also taken that British Airways exploit code here. So this is very, very similar. You can see the same endpoint here. And I've just modified the British Airways code ever so slightly because obviously this payment page is slightly different to the BA one. And we're able to, again, just serialize it, turn it into JSON, and then send it out. Of course, we're not doing that here because we don't own this website, but it would be very, very straightforward. Again, it's just a few minutes of work to be able to capture that data and send it out. Okay, so that's a very quick live demo there. So I thought it was worth as well just talking about where PCI DSS fits in here too. So as I'm sure many of you know, PCI DSS 4 that came out several years ago now added 2 new requirements. Requirement 643 around management of JavaScript, having an inventory, managing it, authorizing it, justifying everything, and so on. And 1161 that defines some timelines, as well as managing the headers, security impacting headers on the website. Now, these requirements were put in exactly because of attacks like the British Airways one. So it does address the type of attack that you just saw here. However, that doesn't always mean that it's going to cover all types of attacks. So, Jeffrey, I mean, we've seen different types of attacks, haven't we, where attackers will attack different parts of the website, not just the payment page.
Yeah, I think what's interesting about the standards themselves, right? Previously, as far as monitoring the application itself, right? So there's in the DSS plenty of rules around like WAFs and other security technologies, but as far as watching inside the application itself, while it's running or while it's being loaded by the client, step in the right direction because now we're actually watching what happens, or at least trying to understand what the client's loading inside of the app itself, and not just, hey, what am I serving out of just my own web server or my own instance, or what am I getting back from the client? Something like a WAF or CDN could take a look at. So we certainly get a little bit more of a peek into the application itself to try and detect things like what happened to VA. But certainly since when these requirements were written, that's what was available to base the requirements on, right? Those were the attacks that were there. That was the information that was available. And so they're very closely tied to these types of attacks. And certainly we've seen things that if you're looking for, if you're just looking in the payment page, you might miss, right? It's certainly not just the payment page where we can launch these types of attacks. It can be done really anywhere in the site. What we're looking for is just that it's believable to the end user, right? Would they believe that they would run into a payment flow at that section of the site or that part of their user experience? And that's where we've seen the attackers kind of run away from the payment page, knowing that, okay, well, if the payment processor's in there, maybe they've got some security script in there, or maybe there's a little bit closer look going on in the payment page. And the example that I want to cover next is going to show how some of that's evolved, changed a little bit to try and avoid detection in just the payment page, where these 2 requirements really focus. So it'd be interesting to see if in the far future, if some of these requirements change around a little bit, or if maybe the scoping or something like that changes to try and cover some more of those areas. So certainly, two requirements, step in the right direction. Absolutely should do them if you are covering things like if you're covering things, or sorry, if you're taking cards and you're under these requirements, you absolutely should follow them. But you may want to take another step or two. Anything else here, Gareth? Otherwise, we'll move to the
No, I think we covered
next
everything
phase.
there. Yeah.
Cool. So let's talk about Casio. So Casio, this attack that I'm going to talk about is actually one that was discovered by our own research team earlier in the year, right around January, and so is a little bit different from the VA attack, a little bit more recent. So we'll get to see a little bit of that evolution of how the attackers are trying to avoid some detection, or at least make the story a little bit more believable for the person who's checking out. So, like I say, discovered in January, and in this case, as you probably call it, I was alluding to, attacks everything except the payment page. So deliberately avoiding putting any type of attack or skimmer in the payment page to assist with that detection. And this will serve as an example of that double entry style attack, whereas the British Airways attack is that more classic example of the skim. This is going to be that double entry that we discussed earlier. So the first stage is a loader that brings some additional script into the page. Pretty innocuous looking, right? It's not obfuscated. It's not directly changed around in any way to make it look suspicious. But the only thing that it's doing is bringing in some additional script. And then you'll note the last step that it does is remove itself from the page. Again, trying to keep a low footprint, trying to avoid leaving behind a bunch of evidence, so that someone who's really going in and trying to understand what's happening with the site, give them a little bit of a harder time to understand what's actually happening in the page. Of course, this is not what's actually launching the attack. That comes in a second stage, where we do have some obfuscated code, some of which we've deobfuscated here and some of which still obfuscated. Very simple concealment of the very simple obfuscation of the script itself, so that or sorry, very simple obfuscation, so it's easy for us to take apart. But certainly there are more complicated ways to go out and obscure this type of data. And another thing that it does is use a different variable name every time it gets a victim, to make it a little bit harder for someone going through in like a debug capacity to see, okay, I see the same variable showing up every time, or trying to enumerate or list variables makes it harder to detect.
One of the questions
Okay.
I had when I jumped into kind of this part of the industry was why attackers so often will have these multiple different stages. We saw the first stage there, and now there's a second stage there. So is that something maybe you can just touch on a little bit?
Yeah, the multiple stages, primaries for detection, right? Just avoiding being detected in the first place. But some will actually use that two-step to avoid launching an attack in certain situations where they believe that it might be a session that has additional security tools, or a session that has already been attacked. This one did exactly that, where once it had been loaded, once you'd gone through the attack one time, so our researchers, when they're actually going through this process, it would use either a domain or IP address to blacklist that victim and not attack them again, right? So that way, again, security researcher, I'm going back, I'm trying to repeat it over and over so that I can either understand it or document it. Makes that process a lot more difficult. And this might be an area where, if you're starting to look at some of the systems that use something like a scanning routine, or like a regular check, you might have a little bit of difficulty in detecting something like this, where if they're able to identify, okay, I see the same IP address loads this script at the same time or in the same frequency constantly, the attacker may say, okay, well, I'm not going to attack those pages or attack those sessions so that I avoid detection. Right, can be a very interesting way for them to try and decide when to or when not to attack. The simplest version is just simply loading the code, rolling a dice, seeing where that die lands, and saying, okay, if it's a If it's a 10, I'm going to attack the session. If it's not, I'm going to do nothing, right? To decrease the
Yeah.
frequency, help avoid detection again. Um, a lot of these attackers want these to sit in here for quite a long time. And then once they're done, they'll actually go to sell that data, but they don't want to be detected before they have the chance to sell the information because that makes it less valuable. Okay, so once the code's actually in here, once everything's set up, once we've got the variable name, what actually shows to the victim is a couple different steps that loads in a modal instead of redirecting to the actual checkout page when the client clicks on their basket and says, hey, take me to checkout. Instead of being redirected, a side pane slides out and set for the checkout. This, of course, is the compromised components that you see here, step 1, 2, 3. We're in the first part asking for shipping information, which of course the attacker is probably not too terribly interested in, but to kind of gain that trust, gain that um, that rapport. Certainly, they're probably interested in some of that as maybe the billing information, probably making that assumption that it's the same. The next step being selecting your shipping method. Again, the attacker has absolutely no interest in this component. It's just to build up the scam, build up the trust. And then once we get to the step 3, actually showing the credit card form or offering PayPal, right? Again, trying to make it look very, very believable, make sure that it actually looks correct, like it belongs in the page. Once the client's entered all that information, once they get into that third step and hit confirm, what they receive is an alert that says, hey, please verify your billing info and try again. This, of course, is the attacker covering up the last part of their of the attack itself, bringing them back around to the actual checkout page once they dismiss this alert. So then redirecting them to the checkout page where the attacker will no longer do anything in that session. So as long as this person goes through and actually makes a checkout for their cart, they'll receive their items. The merchant receives their payment. The payment processor, of course, sees all the signals that they expect from that payment session, because it is in fact a legitimate payment session once we get beyond this part of the attack. And so that's where the double entry name comes from. Having to enter everything twice, and to the victim, right? Everything seems fairly legitimate. It's not something that you would pick out directly. These take a lot of different formats. We've seen some more complicated ones where they'll actually replace or actually make a call out to payment processors to pull down what looks like the exact same page, or inject an iframe that does duplicate the legitimate frame as well. So even closer than adding this whole new modal component. This one's quite interesting, seeing as it's pretty bespoke for this site. Just taking a look
I'm
at my notes here.
pretty sure as well, if I was looking at that as a payment form, I would probably fall for it. It looks completely legitimate, doesn't it? If you're trying to make a
Well,
purchase, you've got, like you say, you've got those options, PayPal or stick your card details in. It looks perfectly normal and legitimate. This is one of the things with attacks. They so often will look identical or as close as they possibly can to the original one. And
yeah.
again, it just draws people in, doesn't it? It makes people feel that everything looks correct and builds that trust, and they put the details in.
Yeah, and to me, it's almost reminiscent of where you'll see, like even like phone scams, where they'll call and say, "Oh, we need all this other information too," right, to make it seem more believable before they go straight for the payment information, right, rather than just jumping straight to the brass tacks of it and saying, "Okay, give me your credit card info." It's, "Hey, give me all this other information, and are you sure you want this, and how fast you want it shipped, and all that," to get that rapport, to build up get you clicking through things so that you're focused on what's in front of you and not really looking around to say, oh, hey, well, maybe this is not quite right. So it's really starting to take some more pages out of the book of, showing that there's a little bit more maturity in the attack now compared to what they have been. Like I say earlier, the British Airways one, being a couple years ago now, in this kind of timeline of these attacks, that really is very, very early compared to what we see in the wild now. This is a quick look at what some of the exfiltration looks like. Of course, they're encrypting some of this information as it goes out. Again, part of that's to make it look more legitimate, right? The payment processor is going to do the same. They probably tokenize that information when they send it, and so they're doing the same here, sending all of that information along so that they can access it later. And in this case, we were actually able to take a look at some of those decrypted payloads just to show like where they're going, what they contain, all of that information, and of course, a lot more details available in the blog article that we have on that particular attack, which all of this is based on. That's available just on our website as well. It's just publicly available. You can go straight to it. I think what we want to talk about a little bit too is that these two examples, right, are examples of something that is directly malicious, something that is an attacker that has a malicious goal in mind, right? They want that payment info to sell or otherwise, but there are other ways to get kind of the same result by accident through either your own design policies, things that developers or even marketing or other groups might do. And so I want to kind of explore some of those ideas before we get on to some of the defenses or otherwise. Gareth, you want to cover some of these parts
Sure.
here?
Yeah, what I thought was interesting here, as we were sort of talking about, JavaScript as a language is very permissive. It's a big selling point for JavaScript. It's also something that the attackers can use. So this slide was a little bit facetious, to be honest with you, because I was saying, if you're using tracking technologies, it has a number of different pros. You can get insight from your users in terms of how they're using it. We've seen examples of sites that will track everything that a user is doing. There are sites like Hotjar, for example, really useful from an understanding what your customers are doing perspective. You can see lines drawing across the website as their mouse is moving. You can see keystrokes being entered into text boxes and so on. And it's really, really useful. If you're building a website and you want to improve the user experience, these technologies are great. If you want to profile your users for things like advertising as well, not such a big fan of that, but at the same time, from a commercial perspective, having that information is really useful. But all of these things are useful to an attacker too. And what's interesting here as well is that there are cases where attackers have used these tools against merchants. So they've added in these types of tracking technologies. Sometimes it's done intentionally. Sometimes there are things that we've seen misconfigurations, for example, where I saw one a few years ago where Google Analytics had been configured on a website. The way that the website worked was that the payment was actually sent in the URL, in the link for the page. So it was what's called a GET request rather than a POST request, for those of you who are familiar with how the web works, which meant that those values are then being caught by Google Analytics. So you could go in and you could see every single transaction that that company had ever done all through Google Analytics. That was purely misconfiguration. But again, you could imagine an attacker doing something similar to that. Because these tools have such power, because they're able to hook in quite sort of low down in terms of how JavaScript is working on these sites, it will integrate with everything, it'll track everything that's going on. They're very, very useful, but they also carry some inherent risks with them as well.
And that's one of those like legitimate uses of monkey patching, right? We talked about that right at the beginning, where a lot of these will attach to some of the mouse move events or click events to function, right? And it's a legitimate use of that, right? I'm sure a lot of you out there are familiar with some of these tracking technologies, right? And typically included by some of the e-com or marketing teams that want to understand what's going on the site. They can absolutely be a pain. But it is something, it's data that they like to use. And they also behave very similarly to an attacker because, again, like I say, yeah, it's a bit facetious to have the same pros and cons, but it is kind of the truth. And that everything that these technologies rely on is also what the attacker relies on. And we had a similar scenario, it was about a year or two ago, where an attacker, rather than writing their own script to read the page, they just said, "Hey, send me a copy too," just attached onto one of the trackers that was already there. It was already grabbing all the sensitive information. So it's like, hey, why reinvent what they're already doing so well? And so they just attached to the script that was already there and just gave it another URL and said, "Hey, while you're shipping that off, I'll take a copy." And that was the extent of the attack. Very few lines. You're talking about 5, 10 lines of code to affect this.
It's brilliant, isn't it? In fact, monkey patching as well is something that is really useful from a defense perspective. In fact, it's something that Jscrambler uses in its technology as well to be able to see what other JavaScript in the page is doing. So, again, all of these things have those pros and cons. It's something that's really useful in JavaScript. We use it, but then attackers can also use it for malicious purposes too. So that kind of leads us on nicely now in terms of what you can do about this. So if you've got that, third-party code in your site, whether it's, analytics stuff, any, stuff for taking payments, for adding in those pretty menus that I was talking about earlier on, any third-party code has some inherent risks involved with running it on there. You can have, a relationship with a third party, with a commercial entity that is providing that code to you, all well and good, but there's always that risk. In the same way there's a risk that you could get breached, there's a risk that they could get breached, and any of their suppliers could get breached as well. So there are several different things that are available to try to help you. The first one we wanted to talk about here was CSP and SRI. So CSP is content security policy. SRI is sub-resource integrity, which is always fun to say 42 minutes into the webinar. One of the great things with this is it's built into the web browser. So it's some headers that are set on the web server, and it tells the web browser what it should allow, what it shouldn't allow, and what to do about it as well if it detects something that maybe is not expected. So because it's built in, great, it's free. And again, it's great in theory. If you have a relatively straightforward, simple website, it will work great. As soon as you start having JavaScript that's being updated regularly, particularly when it's third-party JavaScript that's being updated where you don't have any control over that, it can become very much more difficult in practice. If you're trying to lock things down on your site, and you're saying, these are the pieces of JavaScript that we want to run, don't run anything else, and one of your vendors updates one of those scripts, then you run the risk then of that JavaScript not running and potentially breaking the functionality of your site.
Yeah, I think where we've seen people be very successful with that is when they have very little script in the first place and control most, if not all. If you have just your script, maybe just a payment processor script, can be a good option. I think another thing too is when you look at a site that is quite complex, does have a lot of components, CSP and SRI are quite easy to do in that moment, right? There's free tools out there that will generate it all for you, and then all you have to do is add the headers. So a little bit of copy paste. Where the difficulty comes from is the ongoing, right? You put kind of the risk in breaking the page while it's running, and then either missing that it's not there, or in the case of SRI, not really having the alerts available to tell you that, hey, something has stopped loading, right? Something's not working anymore. And so the risk really comes from, those two together are actually quite rigid, right? Will prevent unknown script from loading, but the risk comes more to the business then, where we're risking the page not being online, or being unable to take the payment, or just a bad user experience, or something that reduces conversion. That in the e-com environment we really do care about. Absolutely, we care about security, but we have to take payments too, and so it can kind of get in the way of that mission.
Mm-hmm. Yeah, absolutely. So the next one that we wanted to talk about was scanners. So those of you who are familiar with PCI, you probably know about ASV scans. This is different to that, but it works in a similar way. So this is a piece of software. Often it'll be like a headless web browser that is going to that website. It will navigate to the payment page. When it gets there, it'll then look at the JavaScript that's on that page, and it will provide, an inventory and so on, and various different tools out there will do will have different features. So Jscrambler, for example, has a scanner where we use where we inject our agent into the page, and we're able to see the behaviors and so on of what's happening. And other vendors have similar sorts of tools here. It's great when the flow to get to that payment page is relatively static. So if there's, a checkout page that you can always get to, really simple. If you've got a capture, it becomes more difficult because it's very difficult to programmatically handle captures. if you have to have an item in your shopping basket before you can get to the checkout page and your stock is regularly turning over. You can't always just add the same item because it might be out of stock the next time and then you can't get to the payment page. So scanners can often have some kind of rigidity that's built into them, but what's good with them as well is they're really, really quick to get going initially. And then kind of the flip side of that as well is the agent-based monitoring. So again, these are relatively straightforward to integrate, not as straightforward as the scanner where there's no integration needed. But the agent is a line of JavaScript that is added into the page. So it's now JavaScript that's running in the customer's web browser. And because it's running now in the customer's web browser and it's running essentially all of the time, it will see all of the different behaviors that your customers are seeing. So it'll see what the JavaScript is actually doing. If you've got A/B testing on there, it will see both of those different flows because some customers in the A branch will be running in their browsers, customers in the B branch, it'll run in their browsers as well. It'll capture all of that. It will also cover things like with payments. If you use multiple payment processors in different regions, it will load for all of those different regions where you have customers. So again, you'll get that full coverage of exactly what your customers are seeing.
Yeah, geography was one I was going to bring up as well, because we also see where certain scripts that collect PII will serve different versions if you have a site that's available in an area that has to abide by GDPR or CCPA, and then you have coverage in areas that don't. You might get different versions of different scripts in those areas. And that gives you a little bit of since you're sampling a much larger group of sessions, gives you a better representation of what's actually happening to the client or the entire client base and not just where the scanner is coming from.
Yeah, and actually with you talking about it being a much larger sample, because it's running within the browser, you'll often get those alerts about changes much more quickly. A scanner generally is running periodically. So, PCI DSS talks about running once every week, whereas an agent-based solution is running much more frequently than that. It's running
Yeah.
anytime the customer is on that site. And then just wanted to touch on one last point for the agent-based side of it. There are some, like Jscrambler's web page integrity, that also have additional capabilities, doing things like form fencing, so restricting certain scripts from being able to do exactly what I was doing earlier on. It'll restrict it from accessing the form fields. You can say, only first-party JavaScript is allowed to connect to this. Any third-party JavaScript is automatically blocked from doing that. There are lots of other types of behaviors as well that it can block. So there's some really powerful things that you can do when you're running as an agent within the browser.
And that's kind of the caveat to what I was saying earlier, right? Like, hey, there's no permissions inside the browser. The kind of next piece of that is unless you're using something else that gives you that capability, right? Certainly, WPI is something that can do that, right? Where we can say, hey, only certain scripts are allowed access to certain data. If it comes from my first party, if it comes from a payment processor, I'm perfectly fine for them to handle payment information. Anyone else, I want to deny, I want to log it, I want to understand, what was trying to touch it, where is it coming from, some more of that diagnostic data to really help me understand, okay, somebody configured something wrong, or I have something far more serious going on in the meantime.
Yeah, absolutely. There's some very powerful things that you can do with that. Okay, so the last one that we wanted to talk about here was CDN-based monitoring. So this is content delivery networks. Several different vendors out there providing services around this. They work in a few different ways, but often what they do is they will generate the CSP and SRI that I talked about earlier. They'll do that automatically. So as files are updating, they will generate the new CSP and SRI. So that can alleviate a lot of the problems that come with kind of the native CSP and SRI. What they often do as well is they'll proxy all of the JavaScript that's being served onto that page. That can be really good because then they can monitor what those scripts are doing. But in some cases, it can also run into some problems because if they're proxying everything, some JavaScript may be dependent on where it's been loaded from in terms of what its functionality is doing. So it would need some fairly good testing to make sure that you're not running afoul of any of these things. And often what they're doing is they're running kind of a static code analysis on these scripts. So, they'll tell you that a script is updated, but then from a PCI DSS perspective, you want to know what it's doing because you need to be able to say, yes, this is the script I'm expecting, and it's doing what I'm expecting, and therefore I'm going to authorize it. But when these scripts are minified, when they're shrunk down, when they're compressed, it can be very difficult to work out what the script is actually doing. If a script changes, how do you tell what it's doing? And
And
again,
some of them, Jim,
go
yeah,
ahead.
some of them don't even have those behaviors until they run. Right? It could be dynamically generated, right? Or they
Yeah.
ask for the code after they've already loaded, or something similar with the Casio attack, where they're waiting to generate that variable name or generate. JavaScript can even generate code once it arrives in the page, right? And they may convert the malicious sections back into code once they're actually there. In theory, some of those components are supposed to be deprecated, but I think we all know how that goes in software. Deprecation doesn't exactly happen overnight, and so there could be some leftovers there, and that's where like understanding what the script is actually doing on your site can be a difference in, okay, here's what the script does when your CDN tests it in a vacuum versus, hey, here's what it's actually doing in a real client site, and that's where. Even though it's automating the CSP and SRI, it's still limited to what CSP and SRI can do, and they don't track what actually happens once the script starts running. Right, CSP and SRI really not looking at exactly what's happening in the page. Certainly, you can look at some domains that get contacted, other script that gets loaded, but understanding what info they're touching in the page, are they changing the forms around, are they moving things around on the page? It's not something that can be controlled from there. So you're still kind of limited by the underlying technology.
Yeah, and in fact, one point that I was just thinking of here as well is more recently we've seen some customers moving towards much more dynamic JavaScript generation. So you sort of touched on that there, Jeffrey,
Hmm.
in terms of it being created and run dynamically in the browser. Some customers and other companies out there will generate the JavaScript kind of just in time. So they will create a JavaScript just for you, maybe based on your geography, based on your login details, even things like the transaction details could be put into the JavaScript and then sent to you as a single file.
Yeah,
And things like CDNs will struggle with that type of approach because every single time they're having to load the file, check the file, update the CSP SRI, and send it out. So again, all of these solutions have pros and cons. So whichever route any of you decide to go for, it's very much worth understanding the pros and the cons and seeing how that fits in with your environments too. Okay, so I think that was our last slide, wasn't it? Which brings us on
so
to
unless
a
there's a surprise.
Q&A.
Yeah,
Yeah,
Q&A. Doesn't seem like we've accumulated any questions along the way, which means either we're doing a really good job or really bad. So if there's any other questions that are kind of outstanding from that, love to take those now. I think otherwise, as far as closing remarks, certainly the Casio blog that section is based on, as I mentioned, available on the website. That's it's not even a download; it's just available on the site. We do have a couple other downloads that are available. Of course, you'll get an email with this recording that has, of course, these slides, a couple other materials. If you're interested in what web page integrity or some of our other products can do on your applications, be glad to have that discussion with you as well. To either show you a demo or talk about how your site's set up or any particular concerns you've got. Um, Oh, and we'll include the Casio blog in that email as well. So that'll actually be um, in the email with the recording. So that'll be there for you. Just taking a quick look. Gareth, anything else to keep up with? I think I hit
no,
most of the high points.
I think we are good. So if we give people just a few more seconds in case they're typing,
Yeah.
I'm pretty sure normally you see a little sort of dot 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 when
Yeah.
people are typing. So I'm not seeing anybody. There's no questions in the Q&A section. So
Well, sure.
I
I would
think
say kind of last remark for me would be a little bit to stay tuned. We'll have a couple follow-ons. I think this is the attacks. This is the malicious side. This is I think what people when they get into cybersecurity is what they think about. It's what they think is cool and what they tell their friends about. But I think in some of the follow-ons, we'll start to look at some of the misconfigurations or some of the legitimate use tools that can really have the same effect even though they're put there legitimately, even though they're put there with good intention or even accidentally. We'll take a look at how some of those can kind of find you in the same position with either losing payment information or really any other info you're exchanging with your clients through your web applications. So that'll be in some follow-on, so keep a lookout for that. Otherwise, we'll leave you to the rest of your afternoon, morning, evening, depending on where you are, and look for you in the next one.
Thanks very much, everyone.
Thank you.